So in here we're going to talk about the hyperbolas. So this is the concept of a hyperbola. A hyperbola looks sort of like two mirrored parabolas with the two halves being called branches. Like an ellipse, a hyperbola has two foci and two vertices. Unlike an ellipse, the foci in hyperbola are further from the hyperbola's center than are its vertices. And for any point P that is on the hyperbola, d sub 2 minus d sub 1 is always the same. In this example, the origin is the center of the hyperbola, that red dot in there in the picture. It is midway between the foci. So here, A is less than C for hyperbolas. The values of A and C will vary from one hyperbola to another, but they will be fixed values for any given hyperbola. And in here, we are going to tackle the parts of a hyperbola. So the center of hyperbola, as you see in the picture, that red dot over there, and the branches vertex, that violet dot, and the foci of a hyperbola are inside its branch, that red, the green dot over there. So the line going from one vertex through the center and ending at the other vertex is called the transverse axis. So the quantity of A plus C minus the quantity of C minus A is equal to 2A. This fixed difference property can use for determining locations. So here we have the C squared minus E squared plus B squared, where C is the distance from the center to a focus point. So before I end this video, I will give you some trivia about the hyperbola. So hyperbola was given its present name by Apollonius, who was the first to study the two branches of hyperbola. So Euclid and Aristeas wrote about the general hyperbola but only study one branch of it. So that is the trivia about the hyperbola.